Previously, I explained about rolling resistance. I explained about this rolling resistance. Now, in the previous explained about rolling resistance. Now, I will explain about the air resistance. Now, I will talk about the air resistance. I will talk about air resistance. In this, when the vehicle moves in a road, there will be air resistance that will resist the vehicle in the flowing way. So what are the ways which the air resistance which occur? I will tell you one by one. So the first one will be that will create a reactional pressure against the front of the vehicle. So consider this is the vehicle in the front. In the front here, that will create a reaction pressure. The the vehicle movement will takes place like this due to air. Due to air, which the movement of the air is in the greener side. Whatever I'm showing, so in the greener direction the air will be flow there, which creates the air resistance. Next is the resist the vehicle body. Whatever the orange color body I'm showing, so the body will the air will resist the vehicle body. That is due to the friction from the air and the vehicle. So that is what the resistance in the vehicle body. Next is the causes there is a power loss will be there. That is due to the eddy. Whatever the eddy loss in the airflow behind the vehicle, there will be causes in the power loss. Next is the causes. It will cause the resistance to the movement of the vehicle. That is due to the flow of the air through the vehicle from the ventilation and the cooling. So these will cause the resistance of the vehicle for the movement. So these are the four types of the air resistance which occurs on the vehicles. So next we'll go for the another type of the resistance which occur to the vehicle. So what is that another type of the resistance is the grade resistance. Next is the grade resistance. This is the grade resistance. Grade resistance is given by MIG divided by 100. So what is this grade resistance? When the vehicle is moving it at a specific speeds at a level surface, consider there is a level surface. The road is leveled. See, this is the road. This is the road where the road is leveled. Okay, so it is being leveled like this. This is the surface of the road where I'm showing the purple color line is there. So that is the gradient. Okay, it is it have the angle of theta. So this is what the theta. So here the vehicle is moving at a level surface to moving from up to down at an inclined surface. So an addition work, so there is a work has to be. So now consider the vehicle is moving from up to down, so there is a no additional work has to required for the movement of the vehicle. The vehicle will move on its own on its speed with an increase in the pace. But when the vehicle is moving from down to up, where additional work has to be required for the movement of the vehicle at the same speed at the same surface. So the additional work done in the in the whatever to lift the vehicle from a lower end to upper end, so that is given by here, that is given by the formula what I am showing here, the formula is pi is equal to mig divided by 100. What is this? M is the mass of the vehicle, where I is the slope or the gradient. Slope or gradient, it is a two different. Slope and gradient are same name, it is in different. Slope and gradient are in the same meaning of the road. Both are the technical words which is used in the civil engineering. So slope of the road is called as I, where G is the acceleration due to the gravity. So that is the grade resistance. So next, I will explain about the the losses. There is some losses in the acceleration and the deacceleration while the transmission, there where there is a movement in the road. These are the mm, this is the inertia force due to the acceleration and the deacceleration. Where there is a movement, where there is a movement of the vehicle, there will be sudden jerk or the pullback of the vehicle. So that is known as inertia force. Suddenly when we are moving in the lift, so we will feel like weightless, or we feel like the pulling of the weight in the downward direction. Even though lift is moving in the upward direction, we feel like pulling us in the downward direction. That is known as inertia force. So inertia force due to the acceleration. So you are moving in the upward direction, pulling back in the downward direction. See, this is the lift. So lift is moving upward, but our weight which is moving downward. So this reaction is known as inertia force. So this inertia force is given by P is equal to ma. Yeah, so actually formula is F is equal to ma, but here inertia force is given by Pf. P is equal to ma. A is the acceleration. So acceleration will differentiate in the form of dv by dt. Velocity, if you differentiate, you will get acceleration. So that's what it is been shown. Okay, acceleration. So whatever the equation, yeah, P is equal to ma is there. So m as it is written the same way, m only, but acceleration, it is been written as dv divided by dt. That is nothing but acceleration. Next is the transmission loss. So there is a power, there will be power will be engine in this there will be what when the transmission will takes place from the clutch to engine to gear system. There is a some losses will be there, some power whatever it will be formed. That energy, some amount of the energy will get wasted during the operation from for the vehicle movement. That loss is known as transmission loss. Okay, so exactly whatever the 100% of the energy which has been liberated for the combustion of the diesel or petrol, the exactly that all those 100% of energy will not be used for the movement of the vehicle. Some amount of energy will be lost. That energy is known as, that loss of energy is known as transmission losses. So next is whatever the uh, power requirement. So power requirement, it is, we will see what is the power requirement for the wheels for the movement. So that is given by pp is equal to pf plus or minus pa plus or minus pi plus or minus pj. So this is the one important formula. Just you write this power requirement and the formula for the examination. So these are the 4 points which is been used for the road characteristics. Next, the last is the headlight characteristics, and another is the braking capacity. Headlight characteristics that mainly depends upon the night operation and the night accident rates. So in the night only we use the headlights, and the night accident rates, the number of the accident case will be high or less, that depends upon the headlights. So that's about the headlights. Next uh, next uh, is the braking capacity or the braking characteristics. This braking capacity or the braking or the acceleration or the deacceleration of the vehicle, that depends upon the design and the type of the braking system and the braking efficiency of the vehicle. If the braking efficiency or brake efficiency is defined as the calculation or effectiveness of the brake, so it depends upon the weight of the vehicle and the forces which is being applied for brakes. So that is the braking capacity. So consider the there are the some of the factors are the braking capacity which affects, that are stopping distance. So stopping distance is, these are the two vehicles, the distance, whatever the distance between the two vehicles is there for to stop the vehicle is known as stopping distance. Oversight distance, overtaking sight distance is the vehicle has to overtake the another moving vehicle, so that is the overtaking sight distance. So it is called as overtaking sight distance. Traffic capacity is the, what is the vehicle which is the number of the vehicle which is been taking place in the movement of the vehicle in the road, that is the traffic capacity, or number of the vehicle uh, which is been traveled over a period of the time, or per hour, number of vehicle which is moved per hour is known as, we can call it as traffic capacity. That's all about the factors which affects the characteristics of the road.